The topic for today is going to be radical expressions. Radical expressions are simply square roots, cube roots, fourth roots, that sort of thing. We are simply going to focus on simplifying and performing operations with square root radicals. Okay, so we're going to just kind of start with the basics here and keep it simple. So with a radical expression, remember that's when you're saying what is the square root of something. So if you have this symbol right here, okay, this is your radical symbol. Now of course there are modifications on how people write this, but it looks very similar to your division symbol there, whatever you want to call that. Sometimes people call it a hut, a division hut, whatever. This is your radical. If you notice, there's kind of a little platform here, and then it jumps back up. So this is your radical expression. This is your square root sign or symbol. When you start looking at cube roots and fourth roots and things like that, you'll see values here that are different. So like a cube root would be, there would be a 3 here on this little platform. For a fourth root, there'd be a 4, fifth root, there'd be a 5, etc., etc. Now, if there is no value here on this little platform, you can assume, it's safe to assume it is a square root. People tend not to write the 2 up there. Okay, so anyway, so what we're looking at here is the expression, the square root of 36. So again, the square root is the inverse of something that has been squared or multiplied by itself. So if we look at this value 36, to find the square root, you can simply ask yourself what number times itself is going to give you 36. So I'm hoping you've already calculated this in your head and said, well, if I multiply 6 by 6, that's going to give me 36. Okay, and you'd be correct. Now, here's the tricky thing with radical expressions though. When you're dealing with square roots, it's not just a positive 6 times a positive 6 that gives us 36. You can also square a negative 6 and get positive 36. So when you are finding the square root of a value, you need to make sure that you include a plus or minus symbol. And what this signifies is that the solution to this, the square root of 36, can be positive 36 or it can be negative 36. Okay, so let's try another one. Let's try the square root of 25. Okay, again, what value times itself is going to give us 25? Well, 5. But again, it's not just a positive 5. Negative 5 will also squared give us 25. So our solution to the square root of 25 is plus or minus 5. Okay, let's do one more. How about the square root of 81? Okay, so the square root of 81, go ahead and think about, maybe even jot down what you feel like the solution ought to be. Okay, so hopefully you wrote down plus or minus 9, because positive 9 squared gives us 81, negative 9 squared gives us 81. So the square root of 81 is plus or minus 9, positive or negative 9. However you want to say that. Most people will pronounce this and read this out as plus or minus 9. Okay. All right, so what happens though when we have radical expressions that are not what we call perfect squares? Let me actually bring this back. These values right here, 36, 25, and 81, are what's known as perfect squares because they square root evenly. They're not going to give you a decimal number. They're perfectly squared, I guess you'd say. Some other perfect squares would be 16, 4, let's see, 64, 16 is of course squared is equal to 4 squared, 4 is 2 squared, 64 is 8 squared, etc. Okay, so anything that is perfectly squared is going to be what's considered a perfect square. Okay, and those are the ones that square root beautifully, and they're so easy. Now, sometimes though, you're going to start looking at values that are not perfect squares. For example, the square root of 50. 50 is a value that is not a perfect square. There's no whole number, positive or negative, integer number, that you can square to get 50. So what we have to do is actually to find the simplified version of this radical is we're going to have to work with some factors of 50 and break it down just a little bit. So hopefully you've reviewed factors. Factors, remember, are the numbers that you multiply together to get a value. So what we have to do to simplify this radical, the square root of 50, is to think about what times what gives us 50. Now, there are several different combinations of factors that give us 50. What we want to look for, though, to make our lives easy, is to look for factors and see if there are any perfect squares in those factors, okay? So let's just kind of list out some factors. So we, of course, have 1 and 50. Now, that one's really not going to do us any good, okay? Because it's just going to keep us where we are. It's not going to get us anywhere. We've got 2 and 25. Okay, now if we look at that factor, we've got the factor of 2, the factor of 25. 25 is a perfect square. So this may very well be the set of factors that we're going to use to simplify this square root. Okay, continue on. We have 5 and 10. I think that's got it. So looking at 5 and 10, those are perfectly good factors. However, we don't have a perfect square here. So let's see what we can do with this 2 and 25. All right. So our next step here in simplifying this radical is we're going to actually break it up into the two factors. But since it's all under a radical sign, even our factors will need to stay under a radical sign. Okay, so the square root of 50 is the same thing as the square root of 2 times the square root of 25. Okay, all I've done is break up those two factors into under two radical signs. That's it. Okay, and here's why. If I look at this square root of 25, I know that the square root of 25 is plus or minus 5. Okay, so that simplifies that down for me. All right, now the square root of 2. I don't know what the square root of 2 is right off the top of my head. It's a decimal number, okay, and it's not the, it's kind of complicated. So I want to leave this as the square root of 2. So what I have is the square root of 2 times plus or minus 5. Now when we write out a radical that's been simplified, we always want to put the integer number in front, okay? It's just proper mathematical grammar. So I'm going to take this plus or minus 5. Oh, plus or minus 5. There we go. I'm going to write it down first, and then I'm going to just bring this square root of 2 and write it beside it, okay? So this right here is the simplified version of the square root of 50. Okay, so let me do another one for you really quickly here. Give me another example, and I'll move through this one just a little bit quicker. So let's say we have the square root of, let me think. Let's just do 12. Square root of 12. Okay, break it up into factors. Again, we want one of our factors to be a perfect square. So I'm going to say the square root of 4 times the square root of 3. 4 times 3 gives me 12. Okay, and you want to leave them both underneath your square root signs. So the square root of 4 times the square root of 3 is going to give me the square root of 12. And so now 4 is a perfect square. The square root of 4 is going to be plus or minus 2 times the square root of 3. Well, the square root of 3 is, again, a 3 is a prime number, so it doesn't factor out any further. This is the simplified version of the square root of 12. Plus or minus 2 times the square root of 3.